From Illinois Public Media, this is the 21st Show. I'm Brian Mackey. As we approach the fall and winter months, have you ever felt, boy, I wish Illinois had a more tropical climate? I guess I'm looking at you, snowbirds. I know who you are in our audience. You know who you are. And as it turns out, Illinois did have a tropical climate. You're just 300 million years too late for it. Recently, scientists at the University of Missouri have been able to confirm that all those years ago, Illinois was a more tropical place than it is now. And we even have a pretty good idea of what the ecosystem was like. And believe it or not, it's because there were some new findings. We have actually been able to reanalyze previous findings going back to the 1970s. I should say it's not because of new finding, it's because of a reanalysis of some findings that go back to the 1970s. Joining me now to talk more about this are two of the lead authors of the study. Jim Schiffbauer is the Marie M. and Harry L. Smith Endowed Professor of Geological Sciences at the University of Missouri. Jim, welcome to the 21st Show.
Thanks for having me.
Also with us, John Huntley, Professor of Geological Sciences, also at the University of Missouri. John, welcome to you as well.
It's great to be here. Thank you.
And listeners, you can join us today if you have questions about tropical Illinois or our ancient prehistoric times here in the Prairie State, which was a tropical state at the time, apparently. 800-222-9455 is the number. 800-222-9455. All right, Jim, I'm going to start with you. Can you just tell us a little bit about what we know now about what Illinois looked like 300 million years ago? And, sometimes I say, if you're tempted to use a college-level terminology, maybe you can explain it to me like I'm a smart 13-year-old.
That sounds good. I'll do my best. So Illinois, where the Mazon Creek fossils were deposited, would have looked a lot like the Mississippi River Delta does today. This was the plate where the tectonic plate where Illinois is currently located was a bit further south and a little bit twisted. And the areas up near Grundy County and Will County and Kankakee would have been a lot more equatorial. And we would have been seeing effectively a coal swamp. So this would have been a heavily vegetated area where lots and lots of plant materials were being buried as sea level was rising, building the Colchester coal, and then later depositing the Francis Creek Shale, which is where we see all of the fossils. So it would have been much like southern Louisiana is today, or even further south than that.
So I'm trying to wrap my head around that, and I haven't spent a lot of time in Louisiana. Are we talking swamps? Are we talking, Indiana Jones sort of tropical rainforest? What do we mean by that tropical designation?
Yeah, so absolutely coal swamps. These would have been very, very densely forested, swampy areas. So a lot like the southern end of Louisiana, or even into kind of the Everglades setting in Florida today. This would have been, we would have had a river exiting around there. In this region, and that's where we're getting a lot of the disparate fossils that we see in the Mazon Creek deposits, from these freshwater biotas out into more marine biotas, and that's kind of what our study focused on.
And what was the climate like? I mean, would there have been seasons, for example?
Well, the Carboniferous was the period when these the period that we're talking about here, around 300 million years ago. It would have been quite a bit hotter than it is today. CO2 levels were pretty high, and this is largely what supported all of the vegetation that we get in these vast coal swamp areas. Insects would have been pretty big. A lot of the animals that existed at the time would have been very large. Because we had plenty of vegetation to support them, and a hot climate.
John Huntley, I'm going to come to you now. So we're talking about 300 million years ago. This is the Carboniferous period. Put that in context. Geologic time is such a mind-blowing concept. What? How do we situate that? How long ago was that? I mean, right? Dinosaurs,
Sure. Yeah,
pre-dinosaurs. Yeah,
it's easy to toss. Oh, sorry. Yeah, it's easy to toss around these large numbers, and sort of lose track of sort of the immensity of geologic time. So, 300 million years ago, this was well before dinosaurs even existed, right? This is before the largest mass extinction in the history of life as we know it on the planet. So, this would have been in the Paleozoic era. Um, at this time, life was well established on land. We would have had reptiles and other strange big beasts crawling around on land. As Jim mentioned, the oxygen concentration in the atmosphere was much higher, which enabled um arthropods that live on land to be quite large. So in what is now Scotland, we've got evidence of millipedes that would have been 2 meters long, and dragonflies the size of small birds. So
I'm gonna have
yeah,
nightmares
this is
about
this
this
is
tonight.
pretty ancient.
You're gonna give me nightmares about this tonight with these 6 foot millipedes. Um, what? When did Illinois become the landscape that it is today? And John, I'll stick with you for that.
So what we see today in Illinois is really the result of much more recent geological processes. So over the last few million years, the Earth's climate has changed into one of alternating ice ages or glacial periods and interglacial periods. And so much of the landscape has been formed through the process of these huge ice sheets moving south from Canada across the landscape into what's now the United States. And so you can think of these as large bulldozers that just come through and completely reset the landscape and uh, sort of like lay it flat and bulldoze sediments around. And out in front of those glaciers, you get these big piles of what's called loess. This it's almost like a rock flour that's been ground so fine by these ice sheets, making their way south. And so certainly the landscape now is very different than what it would have been 300 million years ago.
All right, so let me take a moment to remind listeners this is the 21st show. We're talking about what Illinois looked like 300 million years ago. Recently, researchers at the University of Missouri were able to look back at a collection of fossils that were first discovered in northern Illinois in the 1970s. They reanalyzed them with modern technology, which has led to a better understanding of what the climate was like back then and what our ecosystems were like. We're talking about this with two of the researchers behind that study, John Huntley and Jim Schiffbauer. They are both professors of geological sciences at the University of Missouri. You can join us today at 800 222 9455. That's 800 222 9455. Jim, what would somebody have actually seen, right? If we could hop in the DeLorean time machine and go back 300 million years, what would it actually look like to be standing in Illinois at that time?
So it's at least where the Mazon fossils are deposited. What we would have been looking at is very much a river delta setting where we would have had a lot of plant material, a lot of insect material, a lot of arthropods being preserved kind of at that near shore boundary where the river is first meeting this estuary or Gulf of Mexico like setting that we know today. And that would have graded out a little bit from these freshwater biota into fully marine settings where we would have jellyfish and true marine fish and other arthropods like shrimp and bivalves. All of these kinds of organisms were alive and well during the time in the Carboniferous when this was being deposited. So it was a highly diverse ecosystem that we can see, and it provides us with a nice gradient from offshore to onshore in terms of the animals and the plants that we're able to see in these really unique and well-preserved fossils.
So, for those who are unfamiliar, tell me a little bit about Mazon Creek and the fossil site in particular.
Yeah, absolutely. The Mazon is probably, I would argue, one of the most highly collected fossil sites on Earth. This is localities in northern Illinois. There are about 300 individual localities that fossils have been recovered from. The work that Gordon Baird, and Gordon's one of our co-authors on this project. Gordon really spearheaded a lot of the work back in the 70s and early 80s to describe these localities, and they became a really, really rich site or collection of sites for avocational paleontologists and rock hounds and fossil hunters alike to go out and look at all of these really cool materials. The way the fossils are preserved is really pretty unique too. They are captured in what we call siderite nodules. That's an iron carbonate mineral. So it's a really dense nodule that's usually about the size of about a softball or smaller, depending on the size of the organism that's preserved in it. But these things are kind of egg-shaped or oblong in some ways and somewhat flattened. But they're really these dense nodules that are super super neat when you break them open and see these incredibly well preserved fossils inside of them.
Would these be visible to the naked eye to the people who were first there, or did you have to kind of know what you were looking for a little bit?
So what's neat about the way the Mazon sites were found, if you will, or discovered, is that the coal mining industry had come into northern Illinois back in the 70s to expose the Colchester coal. And I grew up in West Virginia, which is definitely a coal mining state. And we have loads and loads of strip mines where effectively the mining companies come in and remove all of what we call the overburden or all the rocks and sediment on top of the coal. And then they expose that coal seam and get everything out of it, right? So where these fossils are preserved is in a unit called the Francis Creek Shale, and that sits right on top of the Colchester coal. And that Colchester coal is what the mining companies wanted to expose back in the 70s in Illinois. So all of this shale then gets kind of chewed up and spit out on the other side of this production process to expose the coal. And when they do this, they pile up all of this talus or waste overburden into these big mounds of kind of we call them spoils piles. So all of this excess rock that they've removed and chewed up gets dumped in these spoils piles, and that's where we get all of people. That's where we found all of these nodules. That's where Gordon was first looking predominantly were all of these big, huge piles of shale and nodules left over from the mining industry. And that's what people started to go chase after or collect once they found that these were really unique fossils.
I was going to say, how I'm curious about that. You know, was there a eureka moment? Is it, or is it, you know, that scientists know that coal mining produces this type of thing with that type of rock formation, or you know, was some Boy Scout in the area and happened to find something and wrote away to a scientist? Is there anything that can be traced back like that?
Yeah, so there's a deeper history than even Gordon's work in the 70s. You know, I was born in 1978, so it's this was all taking place when I was just a very young child. Um, but the history goes back a bit further. There were several really incredibly well preserved plants that were reported by Richardson and a few other folks in some kind of hidden literature in the Eastern Illinois society journals at the time, and even back a little further than that. But they weren't nearly as abundant as what we knew from the coal mining industry. So they were found along the banks of the Mazon River and Mazon Creek tributaries to that. And they were just kind of unique reports at the time. But once the mining industry came in and they were recovering more and more and more of these concretions, that became kind of a big boon for fossil hunters to go check them out. And that's when we found a lot more diversity too. It was originally just plant material.
All right, we need to take a break in about a minute, but before we do, maybe you can just talk briefly about the name Mazon itself. I understand even that has some history to it.
It does. That's a really unique thing. Um, so for as long as I can remember, when I was taught about these fossils back in college, everyone pronounced it Maison instead of Mazon. And it was actually just recently that Danita Brandt, faculty member at, I believe, Michigan State, for most of her career, she was from the Mazon area, and she published some work and provided several presentations at regional and national meetings to tell everybody that Mazon was actually the correct pronunciation. And it goes back to Native American words for thistle, which was the kind of the abundant plant along the Mazon River.
Hmm,
And that's where the name comes from. But yeah, I'm glad we are now pronouncing it correctly, and
correctly,
it's
yeah.
kind of making its way through the paleontological people that work on it
Yeah.
to say
All
it
right.
right.
Well, we
So
are
it's good.
we're going to continue this conversation on Illinois' tropical history after a short break. This is the 21st show. Please stay with us. It's the 21st show. I'm Brian Mackey. We are talking about Illinois' ancient past, specifically 300 million years ago, give or take a couple of years. Recently, scientists at the University of Missouri were looking back at a collection of fossils first discovered in northern Illinois in the 1970s. They reanalyzed them with modern technology, and it's led to a better understanding of what the climate was like back then and even what our ecosystems were like here in Illinois. We're talking with two of the researchers behind that study, John Huntley, a professor of geological sciences, and Jim Schiffbauer, another professor of geological sciences, both at the University of Missouri. 800-222-9455 is the number. That's 800-222-9455. All right, John Huntley, let's talk a little bit about the analysis that happened here. Talk about what work you did on this and why that was different from what might have been done when these were originally found several decades ago.
Sure. It was a real pleasure to work with this data set. So Jim mentioned Gordon Baird, our co-author. So in the 70s and early 80s, Gordon spent just an incredible amount of effort collecting. And so we're talking about 300 individual locations and nearly 300,000 siderite nodules that he collected. And so his original analyses were really quite clever. And so this is at a time when computing was becoming more common in paleontological sciences. And he drafted these wonderful figures showing how the proportions of different types of animals that lived in different environments changed across the spatial distribution of these samples. And so when I came on board with this project, I was like a kid in a candy shop to open up this Excel spreadsheet and see this just incredibly rich data set. And so we were able to use some quantitative methods to um, look at the data and analyze it in more detail rather than break it up into groups of, whether these animals lived on land or in freshwater or in more oceanic environments. We could um, do a more nuanced analysis and treating these as individual species and trying to understand their distribution in space. And so what was really gratifying is that Gordon's early work essentially established that there were two communities preserved here, the freshwater community with organisms that lived on land getting washed into those freshwater communities, and more marine influenced ecosystems that were preserved there. And some recent work had challenged these ideas And it was good timing. It was shortly after this new paper had been published challenging Gordon's original ideas that we had Gordon's original data and were able to directly test some of these assertions. And Gordon's ideas held up quite well. They're very clearly a distinction of freshwater ecosystems and terrestrial organisms that are getting washed into those getting preserved. And then as you move towards the south and west, you have a much stronger marine influence. And our newer analyses showed us that there were even more subtle differences than what Gordon had originally detected with sort of a gradation within the oceanic system or the marine system as well. So yeah, Gordon's ideas held up, and then we were able to see a more nuanced view even of that.
So you're mainly looking at data? Are you actually looking at physical samples as well
Well, we
or is this,
did we
yeah,
did both.
yeah.
Yeah, yeah. So, and this sort of is the I think one of the fun things about working with Jim. Um, his expertise is much more in how these exceptional fossils are preserved and understanding their chemistry. And so I worked mostly with the spreadsheets and with the data. And Jim was actually able to work with Terracelli, one of our colleagues, and others using micro CT of the actual fossils themselves to image how they're preserved within these nodules. And so we were able to tie together the paleoecology that I'm really interested in studying with what we call taphonomy, how fossils are actually preserved, and sort of bringing them all together into one big model that explains how these organisms lived, what their ecological structure was, how they were preserved, and how that all ties in to reconstructing the ancient environment.
Well, maybe we can talk about micro CT and Jim. I'll come back to you for that. I gather CT that this is the same sort of thing that somebody might experience in a medical clinic, but repurposed for different types of research. Yeah.
Yeah, absolutely. Micro CT is effectively the same thing as a hospital grade CAT scan, but smaller and lab based instead. And we are able effectively to take these concretions that have the fossils and put them into this machine and using X-ray beams see inside of them. So we can see what kind of fossils there before we ever even break the nodule apart. But more than that, we can see differences in density within the concretion itself, which give us some clues mineralogically as to how the processes of fossil preservation were occurring. And to kind of build off of what John said, um, when we have these when we know these settings that these animals were living in, these freshwater settings into transitional settings into more marine settings, we have a difference in the chemistry of where they would have been buried. We have a difference in the sediment type. We have a difference in the water type. So this all gives us kind of different starting points for how these animals would have been preserved across this shorefront gradient from onshore to offshore. So it was a really kind of a nice way to develop a model and test the model using these modern techniques that we have that weren't available back in the 70s and 80s.
How do you know when you take a rock, you stick it in a CT machine? I mean, how do you know, oh, this is 300 million years old and not say, something a kid made on a playground 30 years ago?
That's a good question, and geologists have been doing this kind of thing for a very long time, and we use a lot of what we call relative dating techniques and absolute dating techniques that we kind of cobble together to find our best fit age for all of these types of scenarios. So a lot of times, the way that we'll do this is we can find truly datable rocks in the record with radiometric isotopes and various other techniques that we use for applying a numerical age to rock. And we'll find those around the world. They don't necessarily have to be in Illinois or in the same sequence or whatever. But what we'll do is if we find comparable fossils in other places where we've been able to establish a date, we can then correlate those globally. So we can say, oh, well, these rocks match those rocks, and these fossils match those fossils, and we know that the age of those are 300 plus million years old, or whatever the case is. So it's kind of a big puzzle. You can think of the sedimentological record or the Earth's record of rocks as a big sequence of puzzle pieces that we're all trying to fit together and put together in a logical story.
John, let me come back to you, and or let me actually take a moment to remind listeners this is the 21st show. We're talking about what Illinois looked like 300 million years ago. This was during what we call the Carboniferous period. We're talking about that with Jim Schiffbauer and John Huntley, both professors of geological sciences at the University of Missouri. They have reanalyzed some fossils and data about those fossils that were collected in northern Illinois in place called Mazon Creek in the 1970s. They've used modern technology and data analysis techniques to have a better understanding of what the climate was like here back then. 800-222-9455 if you want to join us. A listener, Elizabeth in Clinton, Illinois, emailed in and sent us a link to a map that lets you plug in your address and see what your area might have looked like over the past 750 million years. John, I don't know if you have an opinion on tools like that. If you're familiar with what she's talking about in this case, it's called dinosaurpictures.org. I'm not sure who organizes that, but yeah.
I'm a big fan of resources that allow people to get to know what's under their feet a little better. Yeah, there are wonderful reconstructions, paleogeographic reconstructions available out there. Another one that I'll plug is an app called Rocked, ROCK apostrophe D, and it's put together by scientists at the University of Wisconsin and supported by the National Science Foundation. And it's a free app. You can put it on your phone. It pairs with GPS and links with a global database of geologic maps, and it will tell you the age of the rocks, the types of the rocks, the fossils that you can find, published papers on those rocks. And it is just an incredible tool, both for a professional or avocational rock hound. I use it all the time when I'm on a road trip. Absolutely love it. And you can also find links to paleogeographic maps like that as well. So uh, absolutely go out there and download it. An important service provided to you by federal research dollars.
There's an interesting plug. Has you maybe this is an interesting time for federal research dollars. Have either of you heard of, since you brought that up, any sort of geological research being affected by what is the how do I characterize it? Significant cuts to federal investment in scientific research.
Yeah, unfortunately, it's this is the situation that we live in at the moment. A lot of earth science related programs have had reasonable or large scale budget cuts. I know NASA, for example, has lost a lot of funding in its earth sciences divisions. Um, and similarly, things that studies that may address climate change, future climate change, are under the microscope at the moment as well, depending on, what uh, what the goals are of those studies.
I think I was talking to somebody recently who said that basically it seemed like every grant with the word carbon in it had been targeted, regardless of whether it was actually sort of pro fossil fuel. Even if it just had the word carbon in it, it was targeted. I don't know if you have any insight into that or have seen anything like that in your areas.
Yeah, there's a big list of words
Yeah.
that we're all
Wow.
aware of that are, that are challenging words to use at the moment. I mean, even words that the way that we use them in a scientific fashion might be different than the way the administration is viewing them. For example, with limitations to DEI initiatives, diversity, equity, and inclusion, we often use diversity as a metric in paleoecological studies. So when we're talking about diversity as a study, we're not talking about the way that it's often viewed, I guess,
In
in
like
a
a
more
sociology
colloquial way.
context. Yeah, yeah,
Exactly.
yeah. Huh. Interesting. All right, let's go to the phones. Dave is calling from Sycamore. Dave, thanks for calling in.
Thank you. I had a question for your guests. I've been a fossil collector for almost half a century, since my first teenage find, all around the country. I live in north central Illinois, and I was a member of one of the largest clubs and did some collecting in by Coal City in the Mason Creek Formation. Now, everyone else was looking for those concretions. They were all looking to find a Tully monster. But I climbed up the tailings pile, and way higher up, I found a little bit of what appears to be slate or shale that had distinctive fossils in it. And it was crumbly. It was a grayish color and appeared to be ferns and other such. Because that was so much higher in the tailings pile, is it possible that that is the much older, the area that you are researching, and how can I get it identified more positively and dated?
All right, Dave, thanks for the question. Jim, I'll come to you for that.
Yeah, Dave, thanks for the question. Glad to hear you're out there collecting fossils and have been for a long time. Yeah, so I mean, in terms of figuring out exactly where that came from in the overburden, we could do kind of we can guess in terms of, yeah, if it's closer to the coal, then it might be the top of that tailings pile, but that's kind of artificial man-made stratigraphy that we've imposed on it. Um, so it'd be interesting to take a look at that. I know that there are certainly fossils that are preserved outside of the concretions within the Francis Creek Shale as well. Um, and a lot of those, like you just said, are going to be plant materials and things. Shale's a great carrier or rock that can preserve fossil materials as well, especially robust materials like plants and ferns and things of that nature. Um, in terms of getting it identified, I would take some photos and send them to your local paleobotanist. If you can find one in the state of Illinois, we'd be happy to help as well here. We can try to find some folks that do the botany side of things and see if
Hmm.
we can get you an ID on it. But yeah, those kinds of fossils are preserved all over the Carboniferous outside of Illinois as well.
Well, it's been a fascinating conversation. Jim Schiffbauer and John Huntley, professors of geological sciences at the University of Missouri. Thanks so much for being with us today on the 21st Show.
All right, thanks for having us.
And we will have links to some of the resources we talked about during our conversation on our website, 21stshow.org. More to come after a break. Stay with us.
Support for the 21st Show comes from listeners like you and the Des Moines Arts Center, located in Iowa's capital city, featuring works by regional, national, and international artists of the 20th and 21st centuries. Details are at DesMoinesArtsCenter.org.